वर्तन्ते प्रोफेसर् गोपीनाथ के वर्याः एते च एतेषाम् अध्ययनं तु भारते एव सम्पन्नम्। अनन्तरं शोधकार्यार्थम् एते अमेरिकादेशं गत्वा तत्र शोधकार्यं समाप्य अनन्तरं विश्वप्रसिद्धे IISc यूनिवर्सिटी मध्ये बेङ्गळूरुनगरस्थे प्रोफेसर् रूपेण बहूनि वर्षाणि यावत् कार्यं कृतवन्तः। ततः परं सम्प्रति एते न्यूटन् स्कूल् आफ् टेक्नालजि इत्यत्र सीनियर् प्रोफेसर् रूपेण कार्यं कुर्वन्तः सन्ति। एतेषां वैशिष्ट्यम् इत्युक्ते कम्प्यूटर् सैन्स्, आर्टिफिशियल् इण्टेलिजेन्स्, अनन्तरं गणितम्, एतेषां दर्शनशास्त्रेषु अनन्तरम् अलङ्कारेपि महती रुचिः अस्ति। अतः एतादृशाः अस्माभिः अद्य सम्प्राप्ताः इत्यतः एतेभ्यः अहं हार्दं स्वागतं व्याहरामि। निदेशकान् प्रोफेसर् हंसधरझावर्यान् सम्प्रार्थये पुष्पं प्रदाय स्वागतं व्याहरन्तु। एवमेव अस्माकं निदेशकाः प्रोफेसर् हंसधरझावर्याः अत्र समुपस्थिताः सन्ति। तेभ्यः अपि न्यायविद्याशाखापक्षतः हार्दं स्वागतं व्याहरामि। एवम् अन्येभ्यः सर्वेभ्यः अपि हार्दं स्वागतं। सम्प्रति अतिथीन् अनुरुन्धे यत् स्वविशिष्टव्याख्यानं प्रस्तुवन्तु। एतेषां व्याख्यानं सामान्यरूपेण आङ्ग्लभाषायां भवति, मध्ये मध्ये हिन्द्यामपि आम् 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 एतेषाम् अद्यतनविषयः अस्ति न्यायशास्त्रस्य अनन्तरं कम्प्यूटर् सैन्स् इति शास्त्रस्य च मध्ये कः सम्बन्धः भवितुमर्हति इति तत्र केचन दृष्टान्ताः एतैः निरूप्यन्ते। आङ्ग्लभाषायाम् एवं सामान्यरूपेण हिन्दीभाषायाम् एतेषां व्याख्यानं भविष्यति। मध्ये किमपि नावगतं भवति चेत् प्रष्टुं शक्यते, तदानीं तत्र यथाशक्ति अनुवादः करिष्यते।
संस्कृतभाषायां वक्तुं किञ्चित् क्लिष्टं भवति। आङ्ग्लभाषायां भाष्यं करोमि। Hello? Yeah. Is it okay? Yeah. So my background is in computer science. So my interest is in understanding Indian thought systems, and invariably it turns out Indian thinking is quite different in many ways to other systems of thought. And you can see it very clearly in our food, for example. Our food is quite different from rest of the world. Our music is also quite different, okay? And our thought systems are also many times quite distinct, okay, from others, okay? Whether it is Hindu thinking, Buddha thinking, Jaina, I mean there's a lot of difference, unusually different from other systems of thought. So my thinking about if I'm working in computer science, if I can understand what our Indian ancestors thought about things, how it is useful even currently, is something of interest to me. Okay, is it understandable what I'm saying? Huh? Very clear, or is it everybody understands what I'm saying? Okay, please don't hesitate to stop me if you don't understand it, okay? Because the idea is more about making some progress in understanding that there is a lot in our traditional thinkers who have thought deeply about some things, and their corresponding ideas in computer science. I just want to show a bit of it today. Okay, so that's my goal. Okay, I will go into some details. It might be not completely understandable, but I'm going to point it out those possibilities. You can study them in detail later if you want to. Okay, is that clear? Okay, so you can go to the next slide, please. So I'm just mentioning that in the Indian tradition, there are multiple approaches to understand reality. Of course, what is reality is what exactly is it is always a big issue for everybody. Okay, and these insights are especially now of didactic value. Didactic means from an instruction point of view, to make people think about it in a different way. Okay, because I mentioned Indian thinking is quite distinct. If you look at our Indian cooking and Western cooking, it's such a big difference, right? There's such a big difference. Okay? Similarly, our thought systems are different. So if you understand why they're different or why they're similar, I think you understand it better. This is a famous shloka in Sanskrit. Eka shastram adhiyano na gacche shastra nirnayam. Okay? You study only one thing, you don't even know what is there in that particular subject. Only if you study other subjects do you understand something. Because you roughly know, yes, that there is some other viewpoint like that. Therefore, you understand your own domain better. Did I make myself clear? If you study only one thing, you will not understand what other thing. For example, if you study only physics and your sarvasam, your whole world is about physics, then you don't really know why it is different from other disciplines. Okay, you have no idea. You have no idea that. Okay. For example, different ways of thinking are there in biology and etc. Okay, which may not be something connected with physics, for example. So you will not even know what is distinctive about physics. Why is it so different? Why is it that it has certain ways of doing things? So you just take it as if it is given to you, nothing. You're not able to think beyond it. Whereas when you see different systems of thought or systems of subjects, etc., then you will understand exactly in what ways this subject is different from that subject. So that's the reason why I feel that it's very important to even current generation of computer science people, they should know a bit about what our ancestors thought and vice versa. Yeah, please go to the next one. So I thought I'll start with an extremely simple one. I think all of you know about quantum mechanics. What is it about? There's something called atomic physics, and you go to try to, basically it's in physics, you try to understand it by taking some entity, look at its parts, keep on looking at down parts, and that's also true in, you mentioned Canada, etc. Right? Basically, you have in various schools of thought in India also, you have notion of anu, okay, atoms, etc. So similar idea, but it turns out in physics they figured out that there are two ways of thinking about it. One is assuming that reality is composed of wave-like phenomena, wave-like. Another is that it's not waves, it is particles. And there are there's big debate between them, which is the right one. And many people say both happen at the same time also. Okay? Quantum mechanics tries to show that both are similar. Okay? One can be translated to other. Okay? So what is basically, you notice that there is a big controversy about the nature of reality. Is it particles or waves? For example, in waves, you use something called Schrodinger's equation. If you see particles, use something called matrix mechanics, and both are equivalent. One can be translated to another. Okay, go to the next slide, please. And so basically, if you look at various people who did it, Heisenberg or Schrodinger, they have very strong opinions, very strong opinions. It turns out similar to this kind of disagreements about what is the nature of reality. We have similar ones in India also. Okay, especially between, for example, Buddhas and the Hindu people. Okay, and basically, if you go to the next slide, they will say that the Buddhas, for example, say that the phenomenon consists of infinity of discrete movements. Basically, the world is particulate. It's basically Kshanikavada. Okay, basically it's nothing continuous. Okay. It is, and our mind is making continuous thing out of it. Actually, the world is full of discrete things. Okay, and the opposite viewpoint from the Hindu tradition is that things are continuous. You can see there is a big controversy there also. Okay, so So there are foundational differences in the way we think about things, okay, and this is valuable, okay. And the reason why, for example, someone like Schrödinger was able to come up with some models of quantum mechanics because he was well versed with Advaita Vedanta. When he was a very small child, not small child, he was a youngster, he had been exposed to Advaita, and therefore these ideas about, you know, certain peculiarities that we see in quantum mechanics, right? The fact that there is interconnectedness across various things, that all those things became much more easier for him to develop as a part of his thinking about what this quantum mechanics, this physics was all about. Okay, am I making myself, is it clear what I'm saying? Okay, because if you find that what I'm saying is not clear, please do raise a hand. Okay, okay, yeah. Okay. Okay, we can try to translate it, I think. Okay, so I think it's tough to do both. Yeah. No, I'm just curious, how many people are having difficulty what I'm saying? Please raise their hands, it's important. Okay, no, don't be afraid, it's nothing is good. If you're having difficulty understanding what I said, please. Okay. Okay. Almost everybody. Okay. Okay. You are able to understand what I'm saying? You can translate? Okay, you can please. I think every slide you can just you can sort of summarize it.
Yeah, sure.
Yeah.
इदानीं साररूपेण वक्तव्यं चेत् एतैः तत्र प्रपञ्चं कथं पश्यन्ति विज्ञानिनः इत्यत्र भारतीयानां प्रभावः तत्र अस्ति इति एतैः प्रतिपादितं. तत्र हैसेन्बर्ग् इति सः अत्यन्तं प्रसिद्धः विज्ञानी अस्ति. तस्य अद्वैतवेदान्तस्य महान् प्रभावः आसीत् तस्य उपरि. सः क्वाण्टम् मेकानिक्स् इति किञ्चित् विशिष्टं विज्ञानमस्ति. तस्य सिद्धान्तस्य निरूपणे सः अनेन प्रभावितः आसीत्. तेन उपयोगः अनेन प्राप्तः इति एतैः उक्तं. ततः पूर्वं किम् उक्तम् इत्युक्ते यथा वैशेषिके परमाणुवादः अस्ति तथैव आधुनिकविज्ञानेपि परमाणुवादः इति अस्ति. अनन्तरं तत्र मतद्वयमस्ति. किमित्युक्ते तरङ्गरूपेण अवस्थानं, वेव् पार्टिकल् ड्युवालिटी इति उच्यते. प्रपञ्चः सर्वोऽपि एवम् अत्यन्तं सूक्ष्मतया पश्यामः चेत् सर्वत्रापि तरङ्गः वर्तते. अन्तिमकणः इति नास्ति, सूक्ष्मकणः इति नास्ति, सर्वत्र व्यापृतः तरङ्गः एकः अस्ति इति. अनन्तरम् अन्यत् मतम् इत्युक्ते एवं कणः अपि अस्ति, ड्युवालिटी इति उच्यते, उभयथा अपि अस्ति. क्वचित् तरङ्गरूपेण भवति तत्, क्वचित् परमाणुरूपेण कणरूपेण अवस्थानं तत्र सूक्ष्मस्तरे भवति इति. एवं एतावता एतैः साररूपेण उक्तम्. अत्र प्रश्नाः सन्ति चेत्
मुझे हिंदी उतना अच्छा नहीं आता, मुझे तेलुगु भाषा मुझे अच्छा आता है. ओके 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 मैं प्रयत्न करूँगा हिंदी में बात करने में, मगर मेरा भाषा सबसे अच्छा जानता हूँ तेलुगु है. इसलिए जरा मुझे भी कष्ट हो गया बात करने. ओके ओके. Then I'd like to hear you translate Sanskrit. It's interesting for me also. Okay, I understand Sanskrit, but I can't speak it that well. Okay, okay. Well, let's go. Yeah. हाँ, वो कैसा हो? वो बहुत बड़ा समस्या है, किसी को पता नहीं. ओके, किसके भी अब तक किसी को भी समझ में नहीं आया कैसा वो ऐसा हो सकता है. क्या बोलते हो आप? एक कुछ एक्सपेरिमेंट किया सब, एक तरफ से वो एक्सपेरिमेंट किया तो पार्टिकल का व्यवहार बताता है वो एक्सपेरिमेंट, और एक दूसरा कुछ और एक एक्सपेरिमेंट किया तो वेव का बताता है, दोनों में बता रहा है। ओके, तो अब तक किसी को पता नहीं क्यों ऐसा हो रहा है। ओके, अब तक किसी को समझ नहीं आता। ओके ओके, इसलिए ये two different viewpoints, okay, is valuable. Okay, and actually they are shown in quantum mechanics, both are equivalent. You have a mathematical model which is quantum, which is particle based, that is what is called matrix mechanics. Heisenberg did it. And then there is the wave kind of thing, which is basically differential equations, continuous systems, that Schrödinger did. And in 1928 or something, they showed both are identical. Okay, whatever this does, this can also explain. But you don't know what the nature of reality is. Mathematically, they are translatable, but we still don't know if there is something behind it, which is makes it both same. Okay, nobody knows what is the reason why it is like that, okay, even today. Okay, there are various theories, but nobody is convinced. Okay, yeah, please go ahead.
इदानीं किम् उक्तम् इत्युक्ते अद्यतनसिद्धान्तः अस्ति विज्ञानस्य वेव् पार्टिकल् ड्युवालिटी इति, उभयथापि तस्य अवस्थानम् अस्ति। अत्र संशयः नास्ति, वस्तुतः एतत् प्रयोगेन सिद्धमस्ति, उभयथापि तस्य अवस्थानं भवितुमर्हति इति। परन्तु संशयः कुत्र अस्ति इत्युक्ते कदा तस्य तरङ्गरूपेण अवस्थानं भवति, कदा तस्य कणरूपेण अवस्थानं, तत्र परिवर्तनं भवति खलु, कथं परिवर्तनं भवति तस्य इति न जानीमः इति। एतत्तु तस्य द्वैतं वेव् पार्टिकल् ड्युवालिटी यद् उच्यते तत्तु वस्तुसिद्धं, प्रत्यक्षेण इत्युक्ते प्रयोगद्वारा सिद्धं, परन्तु तत्र कथम् एवं भवति इत्यतः अस्माकं कृते विवरणं किमपि न लभ्यते, अध्ययनं जायमानम् अस्ति इति।
Next slide, please. Yeah. So what I'm trying to say is that what is very interesting about Indian way of thinking is that without having microscopes or telescopes, because for whatever reasons our tradition did not invent those things. We had some things, we are technologically quite advanced by 15th century, but we did not get into how to make microscopes or telescopes. But including only our native abilities of our human systems, right? We were able to do quite a few interesting things. A good example is number system, which has a recursive structure, or language structures which are also recursive. Sanskrit being a good example of that one. Okay, and so we also had very interesting ideas about our human system itself. Okay, for example, if you go to the next slide, if you look at our recursive means in a bigger thing, if you look at it closely, it is composed of something smaller which has a similar structure to the one that you had. Okay, it's basically, for example, if you take a big number, okay, let us say 4,500. Okay, you can think of it as the number 4 and number 500. If you put them together, 4 into something plus 500 into something, that gives you the bigger number. And it is any number you can take. You can take it as instead of 45 and 00 also. 45 into 100 plus 00 will give 4500. You can take it 450 into 10 plus 0 also. 0 there. So that you have this number 4500. You can decompose it at multiple levels. Each will have a similar structure. Even that 45 itself is 4 into 10 plus 5. Okay, you can keep on doing it till you get. This is similar to the way in Sanskrit, for example, you have both, physical dhatus and other various structures are there, and you can construct any sentence, right, by looking at various various vikaras that can happen in the system, and then you can get the various things, and it's systematic, very systematic. Okay, so that is what I'm calling recursive structure. Okay. So if you look at our understanding in health area, for example, okay, so not health area, okay, at high level thinking area, sorry, because I'm not able to see it very clearly from here, I'm sorry. Okay, so this is about, see, in many traditions in India, we think of our, how we think being composed of things like manas, chitta, ahamkara, and buddhi. Okay. Now, if you think closely, in computer science also we have similar corresponding things. Okay. Basically, manas generally, okay, there are various definitions in India, but I'm taking what seems to be very common. Manas is closer to sensory things. For example, jnanendriyas and karmendriyas, for example. Okay. You first get the inputs. That's like in your computer science, something called input-output. Okay. Then you have chitta. Of course, this is different in different traditions, but there's one tradition which basically says it is the store of impressions. I think Buddhas, for example, say that. Okay. Okay. And you see, that's basically the storage part of it. Okay. And then ahamkara is basically what you call processing, central processing. You have some people say CPUs, cores, number of cores are there. So these are basically that part of it. Okay. And buddhi is the integrative part. Okay, the software etc. that comes into which puts everything together. Okay. You can think of the human computer as in a computational way. Okay. You can translate it if you think. Okay. Yeah.
इदानीं तत्र कम्प्यूटर् मध्ये एकः दृष्टान्तः दर्शितः यथा अस्माकं साङ्ख्ये अहङ्कारः चित्तं मनः बुद्धिः इति विभागः अस्ति तत्र कम्प्यूटर् मध्येपि एवमेव विभागः अस्ति इति यथा मनः इति विषयान् आदधाति विषयान् आदौ स्वीकरोति इति तत्र इन्पुट् औट्पुट् सिस्टम् इति तत्र एकः दृष्टान्तः दर्शितः व्यवस्था तत्रापि समाना इति बुद्धिः इति यथा निश्चयात्मिका बुद्धिः इति व्यवस्थाम् एवं भवेदिति नियमयति सा बुद्धिरेव इति कम्प्यूटर् मध्ये तत् CPU इति तैः उक्तम् अनन्तरं चित्तम् इत्युक्ते मेमरी संस्काराणां समूहः संस्काराणाम् आशयः अस्ति इति चित्तम् अनन्तरं अहङ्कारः इति
I think you have made ahamkara and buddhi same, but I am differentiating it. That's okay. It's okay. Okay. Go to the next slide, please. Okay. Similarly, in Ayurveda also, you will see pitta, kapha, and vata. Okay. And think closely what it is saying. Pitta is basically the metabolic processes. It's more closer to processing. Okay, central, CPU kind of thing. And kapha is basically the thing which holds things together. Okay. It is the stolid part of it. That is the thing which holds the system together. Okay, that is closer to the storage system. And vata is the thing which is the transmitting part. It transmits things across this. Okay, people say if a vata is not good, that means something is getting stuck someplace. It's not getting transmitted appropriately. Again, if you look at current computer science, if people, for example, if you go to the industry, they'll say somebody is working on the CPU side, somebody is working on the network side, somebody is working on storage sides. Okay. Again, you'll see that the same kind of the way the computer systems are designed and manufactured, it seems to have a similar structure to the way our Ayurveda people thought about how our body functions. That there is a part which is doing the metabolic processes. There is a part which is keeping the system intact, like for example, the bone systems or whatever. Okay, various kinds of things. It is closer to the way I think the kapha is. Okay. And then there's a part which actually is the blood, etc., which transmits things across. Okay, that's closer to the network. So these are some, you can see a certain correspondence. Okay, so these are interesting insight. Okay.
इदानीम् आयुर्वेदस्य एकः दृष्टान्तः दर्शितः आयुर्वेदे यथा वातपित्त कफम् इति तत्त्वत्रयं स्वीकृत्य निरूपणं क्रियते तद्वद् अत्रापि इति यथा वातः इत्युक्ते वहनं प्रति तत् नियामकं भवति तत् कंप्यूटर् मध्ये नेट्वर्किंग इति यदुच्यते तेन सह सादृश्यं भजते इति अनन्तरं पित्तम् इत्युक्ते तत्र आहारस्य पचनं भवति तत्र कार्यक्षमं तदेव ददाति अनन्तरं कफः इत्युक्ते तस्य शरीरस्य धारणसामर्थ्यं तं प्रति नियामकः भवति कफः इति तद्वद् अत्रापि इति
Just curious, from your point of view, you are experts. Do you feel that it's a good characterization or is it a mischaracterization? I welcome your inputs also. Okay, how many people think it's a reasonable thing to think in this way? Okay, you see a correspondence. Okay, If you have any opposing opinions, I would be happy to hear them. Okay. Yeah. Anybody has an opposing opinion? Means? In what way?
Word. Accordance to that, patterns system, the input and output is accordance to our meta. Drishtanta isn't about that system is rather.
You are saying that the primary model should be the Pritaka of Vata and rest of it they should follow rather than. Yeah, you can do it in any way. I'm just saying these are analogies. Okay? You can do the analogy in whatever direction. Okay? You can go to the next slide. I think I'll skip this one. Let's go to the next one. Okay, this also will skip. Okay, I think I'm just mentioning that there are interesting ideas even in, for example, when you talk about gunas, rasa theory, for example, it has got a two-level model, whereas you have what are called rasas and bhavas. Okay, and there is an interesting ideas in signal processing or control theory, where you say that if some bhava becomes recurrent, means keeps repeating itself, then it has a different characteristic. It becomes a rasa. Okay, there is I quoted some from Natya Shastra. It basically says that when you remove all the incidental factors, when things become recurrent, then you get a rasa out of it. Basically, this is also an interesting idea from control theory. There is something called control theory in signal processing, which has some connections with what I'm trying. You want to translate it? Yeah.
इदानीम् अलङ्कारशास्त्रे यः रससिद्धान्तः अस्ति तेन सह सादृश्यम् एतैः प्रदर्शितम्.
I think we can probably skip it. I think for the time we'll go to the otherwise we'll get stuck in here. Okay, let's go to the next one. So we'll just get some very high level idea about what I understand. Okay, this might be quite different from what your deeper understanding could be. Okay, so actually I'm not able to see it from there. I think I should look because my eyesight is not that good. Yeah, I'm just mentioning that if I think about computer science, we have this idea that things are top level, bottom up. There are two ideas. Okay, so basically the top level view could be thought of as how to understand something, and that is basically nyaya to me, my limited understanding. Okay? And the Vaisheshika is about really grasping with the reality of what exists there. Okay, so one is looking at pramana, the other one is looking at ontology, or what is called what exists out there. Okay, you can see there is an interesting quote from there is a interesting book called Manameya Rahasya Shloka Vartikam, and here I think it's from there. Okay, I don't know, it may be that he has picked it up from somewhere else, but he says, for example, Nyaya Vaduha Prahuhu Pramana Parinishtitaha. Okay, basically mostly really in the context of pramanas, pranada, etc. Okay, they want to understand padartha jnana. Okay, prameya, what is to be known. Okay, so there is the two-level distinction. Okay, and there is also one other interesting perspective I want to bring it to attention, that nyaya is basically closer to a top-down process. You have certain ideas from top somewhere, and from there you try to derive all the consequences. Okay, Vaisheshika, on the other hand, takes the world as it comes. It doesn't have a fixed notion that the world has to be like this. That's why, for example, in Vaisheshika, some people say there are 25 categories. There might be some other people say it might be 26, or somebody might say it is 25 or 24. Okay, there are some difference of opinion depending on what you add, what you take out, because it's not very clear there is a magic saying it has to be 25. Okay, it's up to you to see the real world, how many things are useful to you. You pick it up as a basis for constructing the system. Okay, so my thinking about this, that it is Nyaya is closer to a top level model, and it is a rational model. Rational means you posit certain things, and from it you derive certain understandings of what could be happening. That's why you have various example. You give it some hetu, from there you have some udaharana, etc., and then you get what you derive from there, right? You have basically certain models of how to do it, right? So it is coming from a certain, you posit that there is a way to reason about things. You have a pramana paddhati, you have these kind of models, and from there you do. Okay, so it is closer to top level model. Whereas Vaisheshika, because it wants to really understand the real world, it has to have a certain a different strategy. Okay, so it's closer to, and you need both top level and bottom up views. Then only you have a complete understanding. That's why fittingly in our tradition, both of them come together. Nyaya and Vaisheshika come together. Yeah, I think you can.
आधुनिकक्षेत्रे बाटम् लेवल् मॉडेल् इति अनन्तरं टॉप लेवल् मॉडेल् इति उभयथा तत्र इत्युक्ते वस्तुदर्शनं तस्य निरूपणं कथं क्रियते, कस्य प्राधान्यं दीयते इति न्याये उक्तरीत्या यद् वर्तते तत् स्वीकृत्य तदुपरि विचारः क्रियते। इत्युक्ते तत्र यथा वैशेषिके कृतं भौतप्रपञ्चस्य यथा विवरणं तत्र ततः तस्य मूलं किं, तस्य सूक्ष्मं किम् इति भौतप्रपञ्चस्य विवरणम् अधिकं न्याये नास्ति। तत्र यत् प्रमेयं विद्यते, यद् वयम् अनुभवामः तद् स्वीकृत्यैव तत्र विचारः प्रवर्तते। परन्तु वैशेषिके तु प्रमाणविचारः नास्ति इति नास्ति, परन्तु यथा फिजिक्स् मध्ये क्रियते भौतशास्त्रे तद्वत् एवम् एतेषां परमाणुतः स्थूलप्रपञ्चः कथम् आगतः इति तस्य मूलम् इति भूतवस्तूनि स्वीकृत्य विचारः अधिकः क्रियते इति।
What do you mean by the top level model? Are you saying it in a computer, or even in a computer? What is a top level model and what is a bottom level?
Okay, let's talk about top level model. Suppose I have to go to Delhi, for example, right? The top level idea is I have to go to Delhi. Okay, but what is the bottom level model? I have to go from here to Sringeri to, let us say, catch a auto or something to go to the bus stop. Go to the bus, wait for the bus, get up on the bus, sit on the bus, okay, and eat some food or whatever, right? All those things small. Okay? There's a, you think at small level, okay, but the top level idea is I need to go from somewhere to here, right? Bottom level, there could be many different. For example, there may not be any food there, and you will be very hungry, or you will do some other things. Okay, it's not constrained by at the top level. Okay, top level doesn't know anything about food, etc. Okay, it doesn't want to also think about it, because if it think about food, etc., it will be not useful to think at that level at certain times. Okay? So the thing is, it may be that the bus is cancelled that day. You may have to go buy something else. Okay. So the thing is, the bottom level ideas, they are constrained by what is around you. Okay. Top level things are closer to your high level thoughts about how you should look at something done. Of course, I will give you more details in a different way later. Basically, you can think what is called in computer science and mathematics, you have what called axiomatic model. Okay. You start with axioms, siddhanta. So if you say this is, for example, what is a line, what is a point, okay, you define those things. And these are all abstract things. They may not have correspondence to reality. For example, in Euclidean geometry, a point has no dimension. Now, have you seen a point without dimension? We have not seen it. Okay. Anything we can, the minute to draw a dot, we know that if you look at it closely, it has got a length and it is probably, if it is circular, it has some radius. It may not be circular, it may be ellipse, but it has got 2 axes, right? It is some amount of stuff is there, right? So there is, whereas mathematically, a point has no dimension. It's a mathematical abstraction. Okay, this is a top level idea. Okay, so you can deal with top level ideas with axioms and things of that kind, but you have to translate to reality later sometime, and the translation is a very tricky part. Okay, as long as you're in the mathematical domain, you can derive something. Whether it actually is connected to the reality is also a big thing to be later decided. It cannot be immediately said that there's a connection. Okay, there are a lot of paradoxes that happen precisely because this kind of issues. I think you can translate and proceed.
इदानीम् एक्सियम्स् इति उच्यते आधुनिकक्षेत्रे. इत्युक्ते मया किञ्चित् निरूपणीयमस्ति, तस्य निरूपणार्थम् अहं किमपि लौकिकम् उदाहरणं ददामि. उदाहरणार्थम् इदानीं कश्चित् तर्कः निरूपणीयः. तत्र उदाहरणार्थम् अहम् इदानीं वदामि वन्यभाववत् पर्वतः अप्रसिद्धः इति. परन्तु वन्यभाववत् पर्वतः अप्रसिद्धः इति लोके तथा दृश्यते वा? तथा नास्ति. वन्यभाववत् पर्वतः अस्ति, परन्तु विषय अवगमनाय किञ्चित् तत्त्वमस्ति, तस्य उपपादनाय एवं मया तत्र प्रतिज्ञा क्रियते. अनन्तरं कथमिति निरूपणार्थम् एकम् उदाहरणं स्वीक्रियते. परन्तु वन्यभाववत् पर्वतः तत्र अस्ति वा न वा इति अत्र लक्ष्यं नास्ति. किञ्चित् मया निरूपणीयं किञ्चित् अस्ति, तदर्थम् एवं लौकिकरूपेण किमपि उदाहरणं दीयते. कश्चन नियमः मया एव क्रियते. एवं तत्र टाप् लेवल् इति एतैः तस्य विवरणं दत्तम्.
Go to the next slide, please. So, for example, if you want to know reality, right, you can have pramana, prameya, etc. Okay. Some examples are pratyaksha, for example. Charvakas have certain, they're accepted by Charvakas, for example. You can have deductive models or axiomatic models. Okay. For example, using anumana. Okay. Or you can have upamana. Okay. And the reason I'm calling it Vaisheshika, closer to Vaisheshika, is because only when you see multiplicity of things can I say similarity. Okay. There's only one thing, Advaita, for example. Everything is same. Then the question of similarity, you have to struggle a bit to say why it has to be, why you need to have models of similarity. Right? If everything is same. If things are different by definition, then I can say something else is similar to this, etc. etc. So if you assume that there are 25 different things, varieties, okay, padarthas, okay, then we can say that this is like this particular thing. Okay, it's like dravya, it is like that, and all those things. You can start thinking of that. So I've also mentioned a few later things. I will come to that later. The computational positivism, Durganikaitya, and other things I'll talk about later. But right now we'll just stick to the top 4. Basically, there are ways of knowing things, and these are all usually top level. This is an example of top level thinking. I'm saying that how I did it is not clear. Okay, some people say pratyaksha is enough. Some people will say, anumana is enough. Okay, some people will say you need upamana. All these things are required. Some people say you need shabda, etc. You need all these things, right? But how did that particular thing come about? Is it because Bauddha say it? Is because Jainas, for example, have saptabhangis. There's a logic which has different from the traditional logic. Okay, so it comes from a top level perspective that this is enough. Upamana is enough, or upamana plus this is enough. Okay? This is coming from the top level, and then you see whether it fits with the real world. What we see. So yeah, I think we'll go to the next slide. I think you want to translate or you want to? Yeah.
इदानीम् अस्माकम् उदाहरणार्थम् एकं शास्त्रं स्वीकुर्मः चेत् शास्त्रस्य एकं लक्ष्यं भवति. लक्ष्य अनुसारं प्रमाणव्यवस्था क्रियते इति. वस्तुतः प्रमाणानि बहूनि भवन्ति, परन्तु अस्माकं लक्ष्यं किम् अस्ति तस्य लक्ष्यस्य साधने किम् उपयोगी भवति मम कृते तदेव प्रमाणं मया स्वीक्रियते, अन्यस्य निराकरणं क्रियते। अत्र एवं युक्तिः इति प्रमाणानां भेदः अस्ति खलु, तत्र एव इयमेव युक्तिः इति उक्तम्।
Go to the next slide, please. So this is, I think most of you must have studied this Nyaya Shastras, Nyaya Sutras of Gautama. Okay, he says, Pratyaksha, Anumana, Pramana, Shabda. Okay, Pramana. Okay, then I think all of this in this. Okay, but there is some commentary given below, which you might have seen. I think if you see Satish Chandra's commentary, he says Charvakas admit only Pratyaksha. Okay, Vaisheshika and Bauddhas admit perception inference. Of course, there is a lot of controversy. Different people have different things, but this is opinion of Mahopadhyaya Satish Chandra. Okay, he's saying that Vaisheshika and Bauddhas admit perception inference, that is Pratyaksha and Anumana. Sakyas admit three, okay, perception, inference, and Shabda. Okay, Nyayikas admit four. Okay, and then Prabhakaras, etc., they talk about Arthapatti and the Bhattas and Vedantis, Abhava and all that. Okay, so there, he's giving various different people perspectives, okay, on how to understand reality. Okay, these come in top level models. Okay, we assume this top level pramanas. From there, we are able to figure out various, if possible, we try to understand the real world.
इदानीं पूर्वोक्तस्यैव किञ्चित् विवरणम् उदाहरणत्वेन अत्र दत्तं। लक्ष्यमस्ति एकं, लक्ष्यानुगुणं प्रमाणं किं भवति, किं प्रमाणं न भवति इति विचारः क्रियते इत्युक्तं। तस्यैव अत्र विवरणं। न्याये एवं चत्वारि प्रमाणानि, चार्वाकाणां तु एकमेव प्रमाणम्। एतत् सर्वमपि लक्ष्यं तेषां किं प्रतिपादयितुम् इष्टमस्ति तद् आधृत्य एवं प्रमाणव्यवस्थापनं तैः कृतमस्ति शास्त्रेषु इति।
Next slide, please. So if you look further down in that same text, it says Tri Vidanam Anumanam. Okay, Purvat, Purvavat, Keshavat, Samanito. Okay, okay. What is interesting is that Purvavat is basically you, from some premises, you derive some conclusion. Okay, and Sheshavat is you see something and you try to figure out how it came about. Okay? And commonly seen, the Samanyato is basically what is called induction. Basically, you see some regularities and you decide that because you have seen it happen like this, it will happen like this in the future also. Okay, so he's defining three parts. But actually, if you look at Vatsayana's, according to Satish Chandra, he says that I think there is the Sandhi Bheda is there. Okay, Samanyato Adrushtam, or is it Drushta? Okay, that Drushta, Drushta, not Adrushta.
No, Adrushta.
But according to this text, okay, this Satish Chandra, he says that Vatsayana interprets it as not commonly seen. Okay, Adrushtam, not seen. Okay, and so that turns out to be a corresponding. If that is the case. If that's not the case, is it?
Samanito Drishtam is the right interpretation. Yeah. Vatsyayana also does in the same way.
But according to, he's saying it's not commonly seen. Okay, Adrushtam is basically not seen, right? Okay. Okay.
Yeah.
So Drushtam is seen. Okay. So I think that depending on the way you do the Sandhi, I think you might get different.
Yeah, I don't know why Satish Chandra wrote like that, okay. But Vatsyayana actually quotes that Samanito Drishtam. Not Adrushtam.
But that's what I'm saying. I also was surprised to see this. But anyway, I thought that if that is the case, if a distinguished logician like Satish Chandra is saying, so if it is the case that Adrushtam is the issue, okay, then this is corresponding in physics. We have something called hidden variables. Okay. Hidden variables means things which you cannot see but have an impact. Okay. Whereas if it is Drushtam, basically what we see from there would derive regularities. Then that's induction. Okay. So that's
there might be some other Pata Bhedas. He might have referred some other copies of manuscripts. Yeah. Okay. What we have studied is Samanito Drishtam only.
Yeah. Okay. I also thought so, but because specifically this Mahopadhyaya is saying it is not commonly said. That's why I'm saying. Yeah, okay. Yeah. You want to translate or we proceed? I think it's
Ah.
all, everybody knows this, I'm pretty sure. Huh? Okay. So we go to the next slide. Okay. So basically the first part, going from premises to conclusions, is deduction. From what you see to deduce where it came from, that is typically called abduction. Okay. What is the best explanation to what you see? Okay. For example, we are all sitting here. What is the explanation why we are all sitting here? There is some multiple reasons, right? For example, some people could not come because of rain. Some people came because it was nice weather. Some people, there are multiple reasons why it happens. So that there is some situation, you want to know why it happened. So basically the best explanation for it. It could be that you all got scholarship, that's why you came here. Or some people got scholarship, some people wanted to learn some things, they came. Okay. What is the best explanation for why we are all here? Okay. Okay, that's abduction. Induction is there is some regularity. The sun rises every day and therefore tomorrow also I expect it. But you can see that induction is not a valid pramana, precisely because according to modern science again, they may say that after 4 or 5 billion years later the sun will lose its energy and will, if you wait 4 billion years, sun will not rise. That's what they say. Okay. Of course, some people might not believe this, but if this is the case, then sun rising every day is not a valid statement to make for all time. Okay? It's valid for the next 10 million years, but not probably if you stretch it to billion years, it doesn't work. Okay, so induction is not a valid pramana. Yeah, please. Yeah.
इदानीम् अनुमानत्रैविध्यं वयं सर्वे जानीमः. तत्र कारणेन कार्यानुमानम्, अनन्तरं कारणेन कार्यानुमानं, कार्येण कारणानुमानम्. एतत् उभयमपि आधुनिकविज्ञानेपि स्वीक्रियते. परन्तु किं न स्वीक्रियते इत्युक्ते सामान्यतो दृष्टमिति. यत्र यत्र धूमः तत्र तत्र अग्निः इति. एतत् अस्य उदाहरणं भवितुम् अर्हति. इत्युक्ते तत्र प्रतिपादनं कर्तव्यं कथमिति. एतदस्ति चेत् तदपि भवत्येव इति. कार्यकारणभावसम्बन्धः तत्र वस्तुतः भवेदेव इति नास्ति. एवं सामान्यतया दृष्टं निरूप्यते. परन्तु इदं प्रमाणं न भवति. इत्युक्ते साहचर्यं दृश्यते इत्यतः सर्वत्रापि एवमेव इति अस्माभिः निर्णेतुं न शक्यते. कार्यकारणसम्बन्धः अस्ति चेत् तदानीम् अनुमातुं शक्यते. कारणमस्ति चेत् कार्यं भवेदेव, कार्यमस्ति चेत् कारणं भवेदेव इति. परन्तु केवलं एतद् विहाय साहचर्यं दृश्यते चेत् तदानीं तत्र अनुमितिः सर्वदापि प्रमात्मिका एव भवति इत्यत्र प्रमाणं नास्ति. अतः तत्र प्रमाणत्वेन नाङ्गीक्रियते.
Okay. So one thing I just want to mention, that deduction is actually turns out to be non-trivial. If you are not careful, you can make lots of mistakes, and it is shown in computer science also. They have a certain types of let us say deducing things, and it's called lambda calculus, and they have to specify exactly how each step has to be done. Unless you get it right, you can make all kinds of mistakes. I think you might have heard about Euclid, right? Euclid is famously known as he has written that book on geometry, and people say their examples are how to think carefully, right? It's widely well known all over the world, Euclid. Okay, but it turns out Euclid also proved that Earth is the center of the universe. Right? Now, how can you prove that Earth is at the center of the universe? Because he deduced certain things, but the direction somewhere he made a mistake. Okay? Because there is no logic or reason why Earth should be the center of the universe. I don't think any of our ancestors in India said that Earth is the center of the universe. They will say Earth is like so many stars, they come and go. Okay, there's so many kalpas, so many yugas, that everything comes and goes, and there's no such thing as this being the predominant part of it. But Euclid, sitting in Greece, because he had done a very good job of geometry, and using deductive style of thinking. But somehow from his, even though he was very successful in geometry, he applied it to a slightly different area, and then he proved some slightly crazy idea that Earth is the center of the universe. So yes, he's very good at knowledge about deduction. Otherwise, he would not written the geometry. But then he made a mistake in doing it in some other area. And what is the reason why it could happen? Because when you do the deductive steps, there's a step, the multiple steps, one step after you follow. Make one mistake somewhere in between, you get everything wrong. right? So I have to be careful. Similarly, when it comes to, for example, there is this Madhvacharya and other people. So basically, if you look at, he calls people who use this inference mechanism, okay, Hetuvadins. Basically, because if you say that something follows from somewhere, then you have to say where you started from. You have to keep on going. Finally, you say, okay, this because of this. Then you say, well, why, how this happened? Because of that. Then you keep on. But finally, where do you end? Okay, that's why Madhvacharya and other people, they basically say this is not a valid way to think about certain things sometimes. Okay, that's what's called infinite regress. Okay? You keep on going backwards. Okay, so I think we just have to stop it. I think. Okay, you can just. Okay, so I think I can just summarize quickly.
इदानीं पूर्वोक्तस्यैव विवरणं दत्तं तैः कार्यं कार्येण कारणानुमानं कारणेन कार्यानुमानम् इति अत्र एतत् प्रमाणत्वेन स्वीक्रियते किमर्थम् इत्युक्ते किमस्य कारणम् इति विचारं कृत्वा सर्वत्रापि वयं युक्तिं दातुं शक्नुमः कथम् इति व्यवस्थामपि दर्शयितुं शक्नुमः एवमस्ति यतः एवमेव भवेदिति परन्तु यत्र उदाहरणार्थत्वेन स्वीकृत इदानीं पश्यामः चेत् सूर्यः प्रतिदिनम् उदेति अतः श्वः अपि उदेति एवमत्र एवम् ऑब्जर्वेशन् केवलम् अस्माभिः दृष्टं कार्यकारणव्यवस्था अत्र अस्ति वा इति वयं न जानीमः केवलं तत्र साहचर्यं दृष्टं प्रतिदिनं सूर्यः उदेति इति अनेन सर्वदापि प्रमात्मक अनुमितिरेव भवति इत्यत्र नियमः नास्ति कदाचित् सूर्यः एव तस्यैव नाशः भवेत् आधुनिकविज्ञाने उच्यते कोटिशः वर्षानन्तरं सूर्यस्य नाशः भवति इति अतः प्रतिदिनं सूर्यः उदेति इति अस्माभिः सामान्यतया व्यावहारिकदृष्ट्या वक्तुं शक्यते परन्तु तत् प्रतिदिनं सूर्यः उदेति इति या अनुमितिः अस्ति सा वस्तुतः प्रमात्मिका नास्ति कस्मिंश्चित् दिने सूर्यः न उदेति तादृशं दिनम् आगमिष्यति अतः एवं सर्वत्रापि कार्यकारणभावं स्वीकृत्यैव व्यवस्था तत्र दर्शनीया सामान्यतः एवं दृश्यते इत्यतः तत्र अनुमितिः नाङ्गीक्रियते प्रमात्मिक अनुमितिः नाङ्गीक्रियते
One more thing that Charvakas say is that there is any statement you make, you can have upadhis, basically that can modify what you say in various ways. Okay, and they say that the number of upadhis is arbitrarily large. Okay, you cannot list all of them. Okay, for example, if I say that sun is shining, okay, I can say sun is shining brightly, sun is shining not so brightly as yesterday, sun is shining in spite of the rain, or whatever. I can put all kinds of things. So the thing is, there is any number of ways in which you can modify a statement. You can keep on adding things to it to slightly modify the meanings, etc. So the thing is, when you talk about any sentence, unless you say that it is completely constructed without ability to add, what you mentioned, vyavaharika aspect of it, there is something, okay, that can negate that particular statement. Okay, so Charvaka's position is that it is not possible to eliminate all the possible. One example of that is, suppose we are human beings. Okay, suppose we can imagine a 2 kilometer long human being, 2 kilometer long. Okay, same as like us, eyes, legs, everything, right? Now, when I say human being, it could either mean us or the 2 kilometer human being, let us say. Okay, but then suppose we can say things, for example, that a human being can enter the room. But if both are similar, then the 2 kilometer person cannot enter the room, right? In a sense, you can see that if I modify that saying he's a human being, but with 2 kilometer is 2 kilometer long, that I add that particular ability to modify that sentence, then that sentence negates the fact that I can come inside the room because it's 2 kilometer long. Okay, so what I'm trying to say is that language is very flexible, and you can put arbitrary kinds of conditions to it. Upadhis, if I understand correctly what Charvakas are saying, you can add arbitrary upadhis, and therefore your regularity notion, okay, it has to be tight. You cannot admit arbitrary upatis to come in the picture. If you allow that to happen, then your induction will not go through. Okay, because you're not sure that you have taken care of all the possibilities.
इदानीं सामान्यतो दृष्टमिति किमर्थं न प्रमाणं भवति इत्यत्र चार्वाकाणां तत्र आक्षेपः प्रसिद्धः अस्ति। व्यभिचारशङ्का तैः सर्वदा आपाद्यते। एवं किमर्थं न स्यात्, एवमपि भवितुमर्हति खलु। एतद् वस्तुतः आधुनिकविज्ञानेपि स्वीक्रियते, प्रमाणत्वेन स्वीक्रियते। यत्र व्यभिचारशङ्का भवितुमर्हति तत् प्रमाणमिति न भवति। यथा तैः एकम् उदाहरणं दत्तं, वयं सर्वे जानीमः, सर्वेपि मनुष्याः अत्र अनेन द्वारेण अन्तः प्रवेष्टुं शक्नुवन्ति इति। एवं सामान्यतया अस्माभिः दृष्टम्, एवम् अस्माभिः निर्णयः स्वीक्रियते, सर्वेषाम् अत्र अन्तः प्रवेशे सामर्थ्यम् अस्ति इति। परन्तु एवमपि सम्भावना अस्ति एव खलु। कश्चन महान् अत्यन्तं दीर्घतमः कश्चित् भूमौ कुत्रचित् वसन् अस्ति, तद्विषये वयं न जानीमः, सः तु आगन्तुं न शक्नोति खलु। परन्तु सर्वेपि मनुष्याः इति यदा वदामः तदानीं सः अपि अन्तर्भवति, परन्तु तस्य तु सामर्थ्यं नास्ति। अतः क्वचित् शङ्का अस्ति, तदेवमेव अस्ति सर्वत्रापि इति वयं निस्संशयं न जानीमः। शङ्कायाः अवसरः अस्ति, शङ्कायाः अवसरः अस्ति इत्यतः एव इदं प्रमाणमिति नाङ्गीक्रियते। परन्तु कार्यकारणभावव्यवस्था यत्र स्पष्टम् अस्ति तत्र एवं शङ्कायाः अवसरः एव न भवति।
Go to the next slide, please.
सामान्य तो इच्छा से इच्छा गुण इच्छा है, तो ये गुण है और गुण किसी न किसी द्रव्य आश्रित ही होता है, तो ये तो सामान्य है। तो इसमें किस प्रकार से व्यभिचार आ रहा है, इसको भी एक बार आप स्पष्ट करें।
इदानीम् अत्र उदाहरणम् इत्युक्ते कश्चन गुणः अस्ति, गुणः द्रव्याश्रितः एव इति अस्माकम् अनुभवानुसारम् उच्यते खलु। अत्र इदानीं समस्या अस्ति इति न, परन्तु सम्भावना अस्ति खलु। कश्चन गुणः स्यात्, क्वचित् द्रव्य अनाश्रितः स्यात्। इदानीं न्यायदृष्ट्या इदं समीचीनमेव, परन्तु केवलं दृष्टान्तत्वेन इदं स्वीकर्तव्यम्। अत्र कोऽपि दोषः नास्ति। न्यायदृष्ट्या गुणः इत्युक्ते द्रव्ये एव भवति, परन्तु इदानीं केवलं तत्र प्रमाणव्यवस्था कथमस्ति इति। विज्ञाने एवं कश्चन गुणः अस्ति इत्युक्ते द्रव्याश्रितः एव भवेत् इति तेषां व्यवस्था अन्या खलु, तेषां निरूपणशैली एव अन्या अस्ति। अतः एवं यत्र व्यभिचारशङ्का भवितुमर्हति तत्र शङ्का अपि भवतु नाम तत् प्रमाणं न भवति इति।
तीसरे अनुसार हम लोग प्रत्यक्ष को दिखाई देता है, तो परमाणु को हम लोग कैसा मालूम होता है, वो कैसे किस जगह से है, कैसा देता है। परमाणु तो कैसा रहती है, एक तो कैसा रहता है, उसके साथ बाद में तीसरा में तो हम लोग उसके पहले परमाणु किस दृष्टि से रहते हैं।
इदानीम् अत्र तु कार्यकारणभावव्यवस्था अस्ति खलु। किमपि स्थूलमस्ति चेत् तस्य अवयवाः सन्ति, तस्य अवयवाः इत्येवम् अन्ततो गत्वा परमाणुः कश्चिदस्ति इति अनुमानं तस्य कर्तुं शक्यते। अत्र संशयस्य अपेक्षा एव नास्ति, संशयस्य अवसरः एव नास्ति इति।
ये परमाणु किस तरह से परमाणु से हम दृष्टिगोचर है, हम देख सकते। ये पहले एक परमाणु हम लोग उसको कैसा कापने कर सकते, एक वो है, एक परमाणु है, दो परमाणु है, या हम लोग कैसा कापना कर सकते।
No, basically for things which you cannot see, either we have microscope or telescope, those kind of things, but even then some things you cannot see, so you can only infer basically by backward reasoning. What is the best explanation to what you see? What is the best explanation? And you posit certain things. The real question is whether your hypothesis about this situation giving exactly only this result, nothing else, that has to be demonstrated. So you have to keep on going backwards. And that's the reason why in physics you started with mechanics, then you went into other things, finally it became atomic physics, then become quantum, and finally you are now at the stage of what's called quarks. And I will say a few words about it. It turns out that there is no clarity about what is the basis for quarks, because you can keep asking what is made of quarks, okay, and you don't know exactly what to say at that point, okay. It's becomes totally mathematical abstractions, and you cannot say anything beyond that. Okay, you have to stop somewhere. Okay, that's what has been the situation.
इदानीं पूर्वमुक्तमासीत् व्यभिचारशङ्का यत्र भवति तत् सर्वथा प्रमाणमेव इति तत् नाङ्गीक्रियते इति, परन्तु व्यावहारिकदृष्ट्या व्यभिचारशङ्का अस्ति चेदपि व्यावहारिकदृष्ट्या तत् स्वीक्रियते, तदेव इदानीम् उपवादितम्। एतत् सर्वं दृष्टान्तत्वेन स्वीकरणीयं, तैः आधुनिकविज्ञाने कथं व्यवस्था अस्ति इति प्रदर्शयितुम् अत्र एवं निरूपणं क्रियते। अत्र वस्तु इदं समीचीनमेव अस्ति, अत्र व्यभिचारशङ्कायाः अवसरः अपि नास्ति। अत्र दर्शित उदाहरणेषु केवलं दृष्टान्तत्वेन स्वीक्रियते, आधुनिकविज्ञानस्य उदाहरणानि स्वीक्रियन्ते चेत् तदानीम् अवगमनं न भवति इत्यतः, अतः यः विषयः अत्र प्रतिपादयितुम् इष्टः सः एव अस्माभिः ग्राह्यः अस्ति। उदाहरणं स्वीकृत्य तत्र महान् विचारः न कर्तव्यः इति।
Okay, we can go to the next slide. I hope it is making sense to people. Is it understandable? Huh? Is it at least useful? More important also, prajana idana kinchit prajana asti va. Is it?
इदानीं विषयः अवगतः वा, किमुक्तमिति? ओहो,
Okay. Is this okay? Yeah. So the next slide, it's, I think all of you must have seen this, right? I'm going to show that, I'm going to try to explain the difference between Indian type of reasoning and Western type of reasoning. Okay. It involves something called the old style Western reasoning was basically what was called term logic. Means you try to understand, if you have a sentence, the validity of the sentence as part of its subject and predicate. Okay. That was done in the Greece, some of those places, and finally it was not workable or whatever. They went to a more mathematical model where you don't worry about the meaning of a particular sentence as in terms of its parts, but you just assign truth or false to the sentence. Basically, the proposition. Proposition means what? You take that it is raining. You don't make any qualifications. It's raining. It is true or false. That's it. For example, you might want to say it is raining lightly, it's raining heavily. You're not bothered about those kind of things. You're only bothered about whether it's true or false. It's raining, it's not raining. So it becomes propositions. You take these propositions and start building your, on top of this, basic level facts. You might call it facts according to the abstractions, according to the mathematical abstractions. This is propositional logic. Term logic, on the other hand, wants to know it is raining. You may want to know what does that it mean with respect to raining. What is with respect to raining? Okay. Why is it raining, not rain? Okay. It wants to understand the internal connections. Okay. That is term logic. So the Western models, they moved from term logic like Aristotle to propositional logic. So in a sense, what has happened is that they have, as we discussed right now, in any sentence there can be arbitrary number of upadhis, okay, ways in which you can modify the meaning by adding things, taking out things, okay, right? So because any statement for that matter you can qualify it, right? Okay, you might say he's tall. Some people say he's tall because he has let us say good genes. Or he's tall in spite of having good genes, okay, in spite of having bad genes, whatever. Okay? There are various ways to qualify the thing. Okay? So you don't worry about those kind of things. You basically take it as a fact that he's tall. That's it. It's true or false. There's no other possibilities. Again, if you go to Jaina philosophy, you will find other things. Okay, you will find Saptabhangi, where you take a statement and you say that it may be true, it may not be true, or it might be not thinkable, whatever, achintya, whatever. Okay, various based. Okay. So, or in the Chatuskoti in Bauddha, for example, you have 4 possibilities, right? So you basically, instead of just being true or false, you admit some intermediate positions also. Okay. Now, what Western model is done is, you move to a abstraction, and then using the abstraction to build on top of things. But at some point you have to decide. For example, I have multiple sentences. Whether this sentence has connection to the next sentence. Again, it's the same problem that we have in term logic. Okay, that's why if you look at current artificial intelligence, there's something people called, they want to understand what is called, given a paragraph, you want to know whether it's a positive or negative. What is it called? Is it a positive view or a negative view? Right? Okay. There are some, basically you need to know, even if you are able to talk about each sentence as a proposition, when you have multiple sentences, you now have to see the connections between the sentences. Okay. That's the same problem that term logic has got in a single sentence. Okay. So for example, if you look at this example, we are looking at the example, no, the previous one. Yeah, you look at, for example, the hill is fiery. Okay, that is the pratigya, right? But if you look at the commentary, he says 1a. He says whether this hill is fiery, or in all its parts, or only in a particular spot. And you can see he is qualifying it. Okay, because he's not worried about the truth falsity as it is. He's saying, is it only in this part of the thing, or is it let us say in only one particular part, etc. So you can see that you can qualify things. Okay, this is usually the case with term logic. In term logic, what happens is that you can try to understand a sentence as a whole in terms of its subject and predicate, okay, or its constituents, and try to understand what is happening. Okay, and that becomes a deep linguistic analysis, and that is what the Indian thinkers have done quite a bit. Okay, Bhartrihari and all these people, they have done deep analysis. What does a sentence mean? Now, because it's so complex, one argument could be that you are getting stuck in this complexity. Avoid it completely. You say that a sentence has only two possibilities, true or false. That is propositional. So you can make progress faster because you have moved from getting stuck in the deeper linguistic analysis of what a sentence, move to a much simpler model, and then use a simpler model, but you will get stuck in the case of having to understand what multiple sentences mean. For example, if you have used, some of you must have used what are called chat GPT and all those things, right? You ask it to do something, it has to understand the complete sentences. It has to figure out what this sentence means with respect to some other sentence. If, for example, it says, draw a figure with this, but not this, but do as with a this figure with a topi on hat, or but without only with one single hand, okay, or whatever it is, right? It has to understand all the complexities of all the things together, right? So the same problem is there, is that the current mathematical logic style has stopped at propositions as a starting point, whereas the older styles of thinking, including Indians, Greek, etc., they use something called term logic, where you worry about the meaning of a sentence as part of its constituents. And there is also a big tradition, I think Anvitabhidana and various other kind, how to, for example, if you take some sentence, how do you get this meaning from its constituents, or is it beyond it? Sphotavada, for example, okay, basically the fact that there is a meaning and it is not totally contained in its constituents, there is something which comes beyond it. That Bhartrhari talks about Sphotavada. Okay. Yeah. Okay. So you can see that in all these cases, the term logic has qualifications. Okay. What is the second one? Yeah. For example, the second one says the smoke. For example, you can dispute about whether it is actually smoke or is it vapor, because you are worrying about what the term actually means. Okay. And then the third one is basically is talking about basically is talking about what are the upadhis. Okay. For example, he is talking about whether it is the fire in a sagadi, what is it, very nicely burning without smoke. For example, when you cook in a properly, right, you have a fireplace without smoke. Okay. Or for example, he talks about a very, very red hot iron ball, very, very fiery, but it's not emitting any smoke. Okay. That's an example of a, you said fiery, it could be fiery because of wood burning with smoke, with a damp wood, okay, or it could be fiery because it's an iron ball which is without any smoke. Okay. So you have to, that upadhi is there, because one thing is because of that, one is behaving in one way, one is behaving, right? Unless you qualify all these possibilities, right? And you can see that our this model of reasoning, okay, this pratigna, hetu and all those things, right? You are working at the level of sentences, intra-sentence ideas. We're not talking in terms of propositional logic, where you take a sentence as a unit and you say whether it's true or false. That's it. You don't think inside. Okay. So that is close. That helps you in mathematical modeling. But the problem with mathematical modeling is that it's abstract. It doesn't qualify. It doesn't have the notions that link. As speakers of language, we want to qualify things. That's part of our linguistic understanding. Okay. We're not completely happy just by saying he's a good poet. We want to say he's a good poet who could do this kind of things. For example, Kalidas is different from some other poet, right? Okay. So he does it in a particular way. Both are poets, but there is some differences you make, right? So you want to, linguistically, we are comfortable with a lot of flexibility in the way we want to say things. Okay. Without that, we'll think language is useless. But the problem is, from analysis point of view, it makes sense for us to have, at least according to the current mathematical models of logic, propositional thing is a better way to start from, because otherwise you get stuck within the sentence itself. You are not even able to come out of it. No, we need essentially equal term logic, because you are doing across multiple sentences. Okay. Same problem is there. Exactly. What you're saying is correct. That's what I'm mentioning that part of it. Okay. That's why, for example, that if you look at propositional logic, it starts syntactic, and then semantics has to be built out. Okay. Whereas term logic, the semantics is there in the sentence itself. Okay, and then so that's exactly different. Yeah, you can proceed. We can explain if you want. You can explain. Yeah.
इदानीं व्याकरणे यथा पदानां कुत्र अन्वयः परस्परं कथमन्वयः इत्यादि विचारः क्रियते खलु, तस्य तादृशविचारः एव आर्टिफिशियल् इण्टेलिजेन्स् इति वयं यद् वदामः ChatGPT इत्यादिकं, तत्र अयमेव विचारः अपेक्षितः इति। एका प्रतिज्ञा अस्ति, तत् स्वीकृत्य तस्य साधनं, पर्वते वह्निरस्ति, कुतः, धूमात् इत्येवं रीत्या उच्यते चेत् कम्प्यूटर् कृते तत् नावगच्छति। पदानां कुत्र अन्वयः, कः अर्थः तस्य इत्येवं तत्र प्रति अक्षरं तत्र बोधनीयं भवति अस्माभिः अत्र। अतः एवं शाब्दबोधप्रक्रिया या वर्ण्यते सा अत्यन्तम् उपयुक्ता अस्ति अत्र आर्टिफिशियल् इण्टेलिजेन्स् मध्ये इति।
So we will just quickly go through the next slide. Okay, yeah, this will keep it. Okay, so basically I am quoting something about basically that in Charvaka thinking that you cannot list all the upadhis. I think that is what okay, it's basically saying that. Okay, a good example I think you can see if you are a cricket fan, right? Suppose you're catching at the boundary, right? Some guy, you get the ball, you throw it up and you cross the boundary and come back and catch it, right? You must have seen that, right? Now you have to decide whether it's a catch or not. Or suppose somebody is horizontal and catches it. It's part of it on this side of the boundary and part of it and then he catches it. Is he outside the boundary or inside the boundary, right? So you can think of all kinds of cases where you have to, somebody has to decide. Or of course standard thing is in cricket is LBW, right? You have to decide whether it actually, could I hit the ball if it didn't obstruct, right? How do you decide that? Okay, it could be that, you have to probably body, right? It has got certain structures. It may hit like this, hit like that, and probably go this way. Unless you model the mechanics, you can't say whether it goes or not. Of course, the computer can do it and they'll show it on the screen. But actually, we don't. I would have to model your model might be different from your model because you are constituted different from this person, right? So it may be that the ball which came, you obstructed it. It might behave differently from you and from him. Probably, who knows? It might have hit the bone in his case, but not the bone in your case. It may move in some other direction. So you can see there is a lot of flexibility in real systems. Linguistically also a lot of flexibility. Okay, and that's what I think this is probably well known. I think you can, if you want, you can summarize quickly and we'll move to the next one. Is it clear what I said, or is it? Okay. No. Okay. Do you want to attempt it? We'll not. Okay, we'll go to the next one. Okay, let's go to the next one. Okay, I think we'll skip this also. Okay, it's the same point I'm making. Okay, just skip this also. Okay, so I think we already discussed this part. Okay, one is that Indian logic is closer to what is called, it has got differences in the way it does it compared to Western logic. Western logic nowadays is propositional, and there are complexities above propositions, whereas in the case of Indian logic and term logic, we have, starting with sentence itself, we have to start working at that level. Okay, and yeah, I think we will skip this part. Okay, I think the question you mentioned is here already. Okay, you go to the one I said in the AI, right? You see the propositional. I have mentioned that what you just mentioned. You can read the last sentence. Okay, propositional logic. Yeah, this is what is called sentiment analysis. In artificial intelligence, it is called sentiment analysis. Sentiment means what is whether somebody is saying something positive about something or negative about something. For example, I can have a review of a movie, and the review can be slightly written with a literary skills. Okay, he doesn't want to say exactly that is bad or good. He will put all kinds of qualifiers. He would say this part of it was good, but that was not so well done. But on the whole, it was good. Okay, something like that. He will put various qualifications. Okay, these three people acted very well, except for this guy who did very badly. Now the question is, do you say that very badly is the most important part, or these three people did well is good? Okay, that is a bigger part. Okay, you have to finally decide whether it is on the whole it's a positive thing or a negative thing, right? So you have what is called sentiment analysis, which is part of current AI, which tells you, given a I mean, you can see that also, right? Suppose you are in human resource HR, you get a, what is it called, a CV. What is CV? Your what is it called in Sanskrit? What would you call CV? Patra, some patra. What patra is it? Parche patra, is it? Okay. Okay. So you have to look at the thing. You have to decide whether the person is going to be called for interview or not. Right? It's a decision, plus or minus. Right? So you have to look at there. All kinds of things are there. You finally have to decide. Right? Now this is an example where even if you say that I have attended this school, I have done this, I have this doctorate, etc. Still, I can decide, no, this is not useful. Yes, this is good, even if the guy hasn't done a doctorate, right? So that is an example of your sentiment, whether it's going to be positive or negative. How do you decide that? Again, as I mentioned to you, this is there in term logic. It is there in Indian logic and older Western logic, Greek logic. But in the current mathematical logic, it is far simpler to bootstrap, start from some level, instead of doing a sentence level. So I'm repeating myself here, but so you can mention this if you want. Is this clear, or we can move? Okay, we can move. No, you can do both, but I think that yeah. Yeah. No, I agree with you. I think the thing is, the older style logic was more linguistic in thinking. The Navinaya has gone to a slightly more mathematical modeling. Okay, I'm coming to that. I'll come to that. Yeah. Okay, I'm coming. Navinaya does. Yeah, Navinaya does closer to the mathematical model. Yeah. Okay. Yeah. Yeah. Basically, it has something called avachedaka. Basically, it wants to delimit what particular term means, so that you constrain the set of possibilities. Okay, and then you do that systematically, and you get, for example, I'll come to that actually. I'm coming to that. Yeah. Okay. The other thing which is interesting about Indian logic is that you have to give udaharanam. Okay, in that 5 steps, right? You basically have pratigna and hetu, all those things. 5 udaharanam is important. Now, essentially, you have to construct an example for what you're saying. Without an example, you cannot do it. Okay, but there are various systems of thought where in current mathematical logic, without giving an example, you can construct a sentence and then proceed from it. For example, you can assume that instead of one type of infinity, there are some other types of infinities. It's a mathematical abstraction, and from there you start reasoning about things. Like in our tradition, we have something called Sasha Vishana, right? Basically, rabbit's horn or something, right? Whether it exists or not, we don't know, but we can argue about it. And actually, there are interesting things, because in a properly set up logical deduction, in some Indian styles of thinking, unless you give a proper example that both the pakshas agree, right? The person who is arguing for and against, right? They have to agree on the example, then only you can proceed. So essentially, you have to construct an example. In a sense, Indian logic is, in many cases, it is constructive. You have to construct an example, then only you can proceed. If there is no possible of construction, you cannot proceed. And both the parties have to agree to it. Okay? This is not the case with mathematical logic. You can live in your own abstract world. You say that these are my assumptions, and from there I logically deduce various possibilities. Whether they exist or not is not clear. Okay? And there is a lot of interesting arguments happened in Indian thinking also here between Bauddhas and Navinaya people. Okay? For example, the Bauddhas will admit that you can construct things which may not exist completely. Okay? Whereas Navinaya people say it has to exist. And a good example is that if you say that you cannot talk about things which you cannot construct, then when you say that you cannot talk about things you cannot construct, you are actually talking about that itself. Right? Is that clear what you are talking about? If you say that don't talk about impossible things, you are actually talking about impossible things in the sentence itself. Right? So there are some interesting arguments between Bauddhas and Navanayakas, okay, on this aspect. That is, either you admit that you can talk about imaginary things, or you can completely avoid it. The real thing is, the real issue is that you want to avoid it also. The very act of talking about it, you are actually introducing it. So there's no way you can actually do it. Okay, so some interesting discussion. Okay, is this clear what I'm saying? Yeah. This is well known in I'm pretty sure you must have.
I mean, these students don't know because they are beginners. So.
Okay. Yeah.
इदानीं किम् उच्यते इत्युक्ते मैथमेटिकल् एका पद्धतिः, गणितीयपद्धतिः इति एका अस्ति. अनन्तरं नैयायिकानाम् एका पद्धतिः अस्ति. नैयायिकानां पद्धतौ कथमस्ति इत्युक्ते कश्चन पक्षः भवेत्. सः पक्षः तत्र वादिना प्रतिवादिना च अङ्गीकृतः स्यात्. उदाहरणार्थं पर्वते वह्निरस्ति न वा इत्यत्र पर्वतः अस्ति इति तत्र वादिनापि अङ्गीक्रियते, प्रतिवादिनापि अङ्गीक्रियते. एवम् एतदेव अपेक्षितं मुख्यं. तत्रैव अङ्गीकृतिः नास्ति चेत् अग्रे न प्रवर्तते. परन्तु गणिते इत्युक्ते आधुनिकगणिते कथम् अस्ति इत्युक्ते तं सः अङ्गीकुर्यादित्येव नास्ति. सः एवं विचारं प्रतिपादयति, अस्य अनेन वादिना यत् प्रतिपाद्यते, यः पदार्थः, यः पक्षः उच्यते, सः पक्षः तेन अङ्गीकर्तव्यः एव इति नास्ति. सः यथा कथञ्चित् तत्र शिरोभ्रमणं कृत्वा अन्यमार्गेण आगत्य एनं सिद्धान्तं खण्डयति अथवा साधयति, किमपि करोति इति. एतत् इदानीं समयः नास्ति. अनन्तरम् अहम् अपेक्षते चेत् सङ्ग्रहरूपेण लिखित्वा उदाहरणेन सह अनन्तरं दातुं शक्नोमि.
I'll try to conclude. Say I have two parts to this talk. I think only one part I will do today. I think we don't have time. Okay, we'll see what can be done. Okay, I'll come to a certain conclusion. Okay. Yeah, we'll go to the next example. So basically, if you look at, if you want to describe reality, one can argue that it's very complex. Okay, and Vyabhichari is possible. Okay, okay. So basically, because reality is too complex, you need to simplify. Okay, to understand it. So you. In current thinking, we have what is called models. Models are basically some simplified version of reality. You work with the models and then see what you can conclude with the models. If it agrees with the real world, then your models are reasonably okay. The abstraction from reality to models is reasonably okay. If it doesn't agree, then you have to change the translation from reality to the model, and you have to come with a new model. Okay, and this is basically a difference between axiomatic and this kind of model. In axiomatic, you assume that certain propositions are always the thing when you start from. There is no way of changing it. There's no, just in a sort of linear model. You start from there and you have to conclude. There's no way of fixing your axioms. Yeah. Of course, historically you keep fixing the axioms, but in axiomatic system, you start with that and then you have to see only the possibilities that come out from it. There's no way to go and change anything else. Okay. Whereas in the other model, you always do a modeling step. Okay, you always say that the world is too complicated. I always model it, but the models may not be exactly correspond to reality. Okay, I will keep on doing it. It's a circular model. You keep going round and round till you get it right. Okay, and if you look at the difference between, you might have heard about AI doing this, AI doing that, etc. It's all the difference between a linear kind of model and a circular model. The AI basically is doing the circular model more systematically. We always had some circular models in our systems, whether it is mathematics, differential equations, all those things, because you always will solve some equations or whatever it is, and then when it is not accurate enough, you go back and change something and keep trying it till you get it right. Okay? But AI does it in a systematic manner. For example, it tells you that suppose there is a sentence. What should come after it? Right? Or within a sentence, I produce this, what should come after it? Okay. How does it do it? It does it by saying that, okay, I give you something like millions of sentences. I arbitrarily chop out certain parts of sentences. And then I feed it to a machine. And then the machine will keep on changing some internal parameters, internal things in it, till it's able to produce the thing it started with. So I can try to explain it one more time. You have a, let's say you take Mahabharata, okay, and then you remove one thing at a time. Okay, you remove the word Dhritarashtra in one sloka. Feed it to the system. Ask it to predict the way it was without the deletion. So the system in the beginning will not know that is Dhritarashtra. It will produce something else. You say it's not right. Again you say try something else. Okay. So systematically explores the possibilities and then says that okay, until it gets that word Dhritarashtra correctly, okay, I will say that the system has to keep changing. So you do it systematically. So basically what you do is you take this huge Mahabharata or whatever, keep removing parts of it here and there. It's called training. You train that system till it is able to fill in the blanks correctly. So it's a circular process. It keeps on doing it. During training, it's going to go out, keep on trying it till it figures out using statistics how many times, for example, Sanjay Uvacha and Dhritarashtra will be coming, right? So that there is a lot of similarity, there is a lot of connection between the two words, the two this kind of sentence, Dhritarashtra and Sanjay Uvacha. Okay, okay. So it's able to predict. In the beginning, it doesn't know anything. You tell it you not get it done it correctly. It will go and check how many times that Sanjay Uvacha and Dhritarashtra have some connection. It will guess that okay, whenever Sanjay Uvacha is there, most likely Dhritarashtra is coming there somewhere. Okay, he predicts that. So, but there are situations, again, if Bhadis you might call it, where that's not the case. You have to discover those cases also, and that's what a AI system during training does. It keeps on doing it till it gets it. So it's a huge, massive exercise. It looks very powerful computers to keep on checking all the possibilities, and it takes sometimes 3 months. For example, if you look at ChatGPT or this thing, they are using some of the fastest machines in the world. They run it for non-stop for 3 or 4 months till they figure out this particular regularities that are there in your text, what you fed it. That's why it takes a long time. And that's why it is a statistical exercise, so it might understand something. Surprisingly, it's able to understand Sanskrit. Quite a few. For example, Grok and other thing, they have digested lots of Sanskrit textbooks, and without you ask it some question Sanskrit and figures out something. Sometimes it does it wrong, that's a different story. But it is surprising that it is purely doing this exercise of circular system. It's not like the linear system. Linear system means you start with a, the world is composed of, 5 things. Like for example, in the past, right, people say it is composed of prapancha, 5 things, right? Earth, this and that, right? Earth and what is it? Air and vayu, this and that. And then from there you try to derive the whole system. Okay, that's one way to do it. Another way to do it is I don't assume that there are 5 things. I'll take whatever is there in the world. I keep on saying, if I miss this, can I, given the structure or whatever I see here, whatever the data, you might call it data, whatever is missing, sorry, whatever data I have got, if I miss out some things, if there is regularity in it, I should be able to predict it. Right? So, in a sense, you do it in Sanskrit Kavya also. For example, you have various, for example, Chandas. The Chandas has got some regularity. The Ganas, right? If you miss out one thing, they know that something is wrong. Somebody tells you Shardula Vikridam, whatever, right? But something is missing. You know that something is wrong there. That's because you have put a higher level structure that's missing, then you have to go and fix it somehow. That's how we normally figure out this corruption in the text, etc. Right? Of course, it's not a foolproof method because I can always have the same ganas being given by multiple possibilities. So there are multiple ways in which you can fix the problem. Okay. So the difference between older computer systems model and the current AI systems is the systematic exploration of the circular model compared to the older systems. Okay. Older systems are closely top down. The current models are much more circular. And because the circular thing, you're never sure about when to stop. And you want to, and if you do it on a very, very large scale, it takes a huge amount of time. Okay. So that's what I'm calling it, the computational. Okay. For example, what I'm calling it the network model. If you see the 2 parts, axiomatic, which starts in the top, or the computational, okay, which is assume a network of ideas. For example, if you take a Mahabharata, right, it's a set of ideas. not look like that, but there's some structure to it, right? The Pandavas are talking to some people, Kunti is there somewhere, okay, and various other parties are there somewhere here and there. There's some structure to the way the things happen. It's not totally random. It's not. It looks to have some sense in it, right? At certain parts of the text, for example, Krishna is talking to Arjuna, right? It makes some sense why he's talking there. It's not totally random. Krishna is not talking to Arjuna in the very beginning part of the, very early part of the Mahabharata. Okay? He's not even there, right? So there's some structure to the whole thing, right? And so in a sense, there is a network of ideas that are there, okay? And this closer to, you might call it Shabda Pramana, okay? Basically, you already know that somehow there is some sense in this part. It's not coming from top down. It is the fact that there is a certain meaningfulness to what you see. Because it's meaningful, there is some network of ideas, a network of things that are out there. And because of that, you are able to fill in the gaps even if something is missing. And that's how we study. For example, if you look at any second standard textbook or third standard textbook, okay, it says fill in the blanks. Okay, Nimnalika something, something is there, you remove this. Basically because the structure is somewhere. And the structure is what helps us to fill in the blanks. Right? And this circular model does that systematically. Okay? That AI all about is that, in my opinion, is pushing the circular model to its limits. But that can only go so far because it's based on good examples. If you give it Mahabharata, etc., it's able to do it. But if you give totally random stuff, it won't figure out anything. Mahabharata has lost a lot of structure. Our current Wikipedia has a lot of structure. Okay? If you feed it Wikipedia and meaningful things, it will figure out a structure. If you totally give it garbage, it will only produce garbage. Okay, that's something you have to remember. Yeah, I think if you can, I don't know whether it makes sense to. Does it make any sense? Huh?
Yeah.
Okay.
But summarize it takes a lot of time.
Okay.
So I'll just.
Okay.
I can summarize it later
Okay.
by giving some examples and.
Yeah, we'll just try to conclude it by a few minutes. Okay, I'll just few more slides we'll just go through. Then I have much more stuff, but I think we'll not be able to do. Okay, I think we'll skip this one. Okay, I'll just show you this one. This example is it's not being shown, is it? Okay, it's not showing there. It's showing on the screen. It's not. Okay. Oh, PDF. Oh, that's it. Okay. Actually, you might see this. Can you turn it around, show it to people. See, this is you can see something going on there, right? If you look at people have done something kind of quantum mechanics area. This is how a vacuum is supposed to look at. Vacuum means there's nothing there, okay? But if you look at the potentials, this is how it is changing. Right? You are thinking that vacuum is there should be nothing there. Why should anything be there, right? But actually, it turns out the potentials, some voltage and things like that. Let's get into. Okay? Actually, they're varying this much because of that something called uncertainty principle, etc. Because uncertainty principle says that you cannot predict certain things, speed, the position and momentum. There are certain things you cannot do. Okay, so if you take vacuum, if you are able to say nothing is happening, then you are able to predict that nothing is happening, right? You cannot do that also. Because of that, it turns out that you need to. The actual reality is very, very. Even if you keep on going down and down and down, as you there is some structure. You remove the structure, you figure it out, go all the way down. But as if you want to keep going further down, there's even more messy things that show up. Okay, there's no magic there. There's somehow it is everywhere complicated. Okay, it is not the fact that it is as you go down, it becomes simple. That's what I was. Yeah, go to the next slide. Yeah. Okay, so basically, I was mentioning there are two models: axiomatic thinking, basically closer to top-down models, linear models, or a networked or cyclic thinking models. Okay, and this actually cyclic model is there in Indian thinking. It's called Druk Ganikaitya. Druk is to see, Ganita is to compute, Aikya is conformal, identity. Okay, so if you look at Indian astronomical texts, astronomy, okay, they have models. They don't say models are reality. You can have, for example, Aryabhata had some model, which was disputed by Brahmagupta and other people. Okay, the models are not important, but important thing is the models you get some results. You are able to predict eclipses, etc. If you're not able to predict eclipses properly, you have to change your model. Okay, and so different models were there. For example, ninth in the 9th century, there are some astronomers who added for predicting the moon, for example. Okay, there's something called, I don't know the translation for this word. There's something called evection, moon's evection. Okay, and that add was added to explain things better. Okay, so the models are not fixed. You can keep changing them, but important thing is finally your answer should correspond with what you see. Druk Ganit Aikya. Okay, what you see should correspond with your calculations, and that is what is computational thinking. Okay? And I think in India it was very prominent, at least in astronomy, and I think in other areas also. A good example of that is that in Sanskrit linguistics, they say that, what is the famous quote, that if you want to understand language, you have to go to the marketplace. What is, I forgot the exact sentence. Okay, the people who speak, right, they are the final authors of what the language is, not your top level derivations. Okay, what is it? There is some quote, I think, in Mahabhashya, I think so. What is exact, right? Yeah. Does anybody know what I'm talking about? I think Patanjali's Mahabhashya has, I don't remember the exact quote. Okay, that is the arbiter of what a language is, what is spoken, not what the grammarians say it is. Grammarians can systematize it. Okay, but they're not the final arbiters. They're not the final authorities on what language. Those people who speak are the language. Yeah. Okay. So that's, I think we'll probably. I think there is some issues about axiomatic things, whether swata pramana or basically parataha pramana, etc. Basically, whether certain facts, they are by themselves, can be said to be true or false, or it has to be some other things. But then if some other things are in the picture, then you have to say what those things are and how they're established in the first place. That also, those kind of issues are there. I think there's a lot of disputation across this in many traditions in India. Go to the next one. I think I want to conclude at a particular. Okay, I think you can skip all this. Okay, I'm just mentioning that there are a lot of complicated things about even derivations. I think all this. Okay, let's skip all this. Okay, yeah, I think let's go to the next one. I think we'll. Yeah, I think basically I just want to mention that we'll just go to the previous one. So basically the difference between linear models and cyclic models. Linear process, basically you start with, from the beginning, some facts you take for granted. This is an axiomatic model, and then you do some computation possibly, okay, and use certain invariants, okay. Whereas it's what I would call an open loop system. I'm sorry, I'm not sure if it makes sense to any of you all these things. Okay, there's opposite to it. There's cyclic models, and it's closer to closed loop because it's you correct things as it happens. Okay? It's slightly more open to possibilities of correction and progress. And I think I'm going to argue that no, not here. We moved it here, but not there. Oh, that's the reason why. Oh, sorry. No, you have moved. That is not moved. We're skipping all these things. Okay, so I'm going to stop at this point here. Okay. Basically, as you can see, there's one famous professor in Indian Institute of Science. His name is Ruddam Narasimha. He has coined the term called computational positivism. It's essentially Druk Ganit Aikya. He's called it computational positivism so that it is understandable by those people who are comfortable with let's say English terminology. So what is it? Basically, reality you have to go through modeling, and then once you model it, you can, depending on the system, you can, because it's already abstract now once you modeled it, and then you can keep that model in your computer or your head or do mathematics or computation on it. You get the results from it and see if the results correspond with reality. If it is closely corresponding, then you accept the model is for the time good, because there are all kinds of upadhis are possible. For the time being, it's working. You be happy with it as long as it works. If something happens which changes the thing, then you have to go round and round. So that's why, for example, astronomy, Nilakantha, the various people are there in Indian astronomy who actually say exactly this one. Okay, basically that your astronomical models have to be revised by consultation with experts every so often, because your way of predicting it will fail now and then, because the astronomy, in spite of it being regular, there are differences, okay, because you know that there is something called precession, right? Every 27,000 years, the polar star changes. And there is much heard about this thing. So that has an impact on our local models, simple models we have. Okay. So depending on which part of the 27,000 year cycle you are, you will have different things. And there's something called Vakya astronomy in India, which is basically even more specific to a particular place. Okay. And then you have to, depending on the place, you have to modify it. I think you might have been aware that, for example, some festivals are, have certain tithis in this country, and in US some there will be some other differences will be there, right? Or various other countries. If you are somebody want to observe Indian tradition elsewhere, you have to look at the local conditions and decide. Okay, so all these things are there. Okay? So the models are important, but the models may need to be changed depending on the context. So it's highly contextual understanding, highly, Kala, what is it called? Kala and Desha and okay, depend on those. You have to actually modify it accordingly. Your Panchangas, for example, they tell you this. Okay. So this is basically a computational positive outlook, and some people claim that this is the only way to understand reality. There's no other magic. So it has got both components, top down and bottom up. Okay, basically top down because you are doing that from the model. You are coming with some understandings what can come from the model. That is the top down part. You have a model is the top down. You derive the consequences. Okay, and then when you look at whether results are similar to what you see in practice, what you see in practice is basically the bottom up things, what you see on the ground. Okay, and you have to see whether they correspond. If they correspond only, then you're right. Okay, so this combines both the thing models. And I was going to get now into the Vaisheshika part from here. Okay, I'm sorry we have run out of time. My apologies. I think we'll stop here. Okay? There is about half the circle is not completed. Okay, my apologies.
एतावता किम् उक्तम् इत्युक्ते अत्यन्तं सूक्ष्मविषयाः एतैः तत्र उद्धृताः अवयवग्रन्थात् अनन्तरं हेत्वाभासग्रन्थात् बहवः विषयाः उद्धृताः तेषां शाब्दबोधप्रक्रिया यथा वर्ण्यते तस्याः एव प्रक्रियायाः अद्य आर्टिफिशियल् इण्टेलिजेन्स् इत्युक्ते तैः अस्माकं शास्त्रात् स्वीकृतम् इति नास्ति परन्तु समानप्रक्रिया तत्र उपयुज्यते इति अतः एतेषां आधुनिकक्षेत्रे महान् उपयोगः अस्ति परन्तु अत्र सूक्ष्मरूपेण अध्ययनम् अपेक्षितं भवति एतैः एतत् केवलम् अत्र दिग्दर्शनं कृतम् एवं कर्तुं शक्यते इति एतत् अनन्तरं साररूपेण किञ्चित् लिखित्वा प्रेषयितुं शक्यते अहं किञ्चित् प्रेषयामि परन्तु बहूनि उदाहरणानि यानि उक्तानि तानि अत्यन्तं क्लिष्टानि सन्ति सामान्यतया सारः अवगन्तुं शक्यते.
Okay, I just also want to, before I conclude, okay, this will be the last concluding statement. It turns out if you introduce what is called quantum mechanics into it, quantum mechanics, they say that act of observation changes the system. Now you can see in this particular thing, it is a classical model. That is, you compute and check. There are sequential things. One thing happens. But in quantum mechanics, act of observing itself changes the system itself. So you need a much more deeper model instead of this one if you want to really handle even the current understandings about quantum mechanics. So it's not this is the starting point. Okay. And current AI is limited to this model. Who knows, if you do what is called quantum AI, then it will be far more integrated with respect to observation and system. Because even the act of making from reality to model, reality is something, you take a snapshot and then you come with a model. But the act of looking at it itself changes the system. For example, I think if you look at, let's say that there is a university and you want to make sure students are not doing some X, okay, and you put certain cameras and other kinds of things, okay, but the very act of putting cameras itself will change the behavior of students. They will do something else to make sure that they are safe with that, but they are doing something else which the cameras cannot capture, right? So in a sense, the act of trying to observe something will itself change the system Okay, like you must have about copying, anti-copying relations. Some people will say they will write it in a hand in the beginning. Now hand is not possible. Then they'll use mobiles. Mobiles are taken out. Then somebody will be doing through some other system. Who knows what other system? They might have embedded. Some people have been caught with an embedded thing in their ears. Okay, somebody is wirelessly transmitting the answers. Okay, so all these are possible. Okay, so what I'm trying to say is that the act of observation in the system. So in here, I have reality and model. That's one act of observation is going. And then from reality and checking with reality whether it's observing, that also is another act of observation. Okay. Now this, if you think more deeply, it turns out to be an extremely complicated thing to really get it right. Okay. And so it's a lot of possibilities are there in understanding system of this. Okay, I think with this I'm going to stop. Thank you so much. I'm sorry if I took much longer than expected. Thank you. That way I only covered half of it. Sorry. Yeah.
एतावत्पर्यन्तं विशिष्टव्याख्यानं प्रदत्तवद्भ्यः प्रोफेसर् गोपीनाथवर्येभ्यः न्यायविद्याशाखापक्षतः परिसरपक्षतश्च हार्दं धन्यवादं समर्पयामः। अस्माकं गुरून् सम्प्रार्थयेत् तेषां सम्माननं कुर्वन्तु। सर्वेभ्यः धन्यवादाः। शान्तिमन्त्रेण सभेयं परिसमाप्तिमेति।